Hi guys, welcome to Jil Ibda American School. Today about our lesson about the area of triangle. It's a very easy lesson. Okay, look to this video and listen.
The essential understanding for this lesson is the formula for the area of a triangle A equals 1/2 times B times H can be derived from the formula for the area of a parallelogram by decomposing a parallelogram into two identical triangles. Previously, students derived the formula for the area of a parallelogram. In this lesson, they decompose a parallelogram into two identical triangles to derive the area formula of a triangle. This problem is key because students decompose a parallelogram into two identical triangles and use any method they choose to find the area of each triangle. This gives teachers the opportunity to see if students can relate the area of each triangle to the area of the parallelogram. Listen and look for students who connect the points to form parallelogram A, B, C, D. Draw a diagonal. And observe that the diagonal divides the parallelogram into two identical triangles. However, some of these students may not make the connection between the area of each triangle and the area of the parallelogram. So, they may count the number of squares in one triangle to find that the area of each triangle is approximately 110 square units. While this is a good estimate, point out to these students that there is a more efficient and precise method that they could use. Ask these students how the area of each triangle relates to the area of the whole parallelogram. Because the triangles are identical, students should understand that each triangle has half of the area of the parallelogram. Then encourage them to use this information and the formula for the area of a parallelogram to find the area of each triangle. Listen and look for other students who understand the relationship of the areas of the triangles and the parallelogram. They may count units to label the dimensions of the parallelogram. The base is 18 units, and the height is 12 units. Then they may use a formula to find the area of the parallelogram. The area of each triangle is 1/2 of 216 square units, or 108 square units. These students show an understanding of how decomposing a parallelogram into two identical triangles and using the formula for the area of a parallelogram can help them find the area of each triangle. This understanding prepares them for deriving the formula for the area of a triangle.
Okay, the area of parallelogram equal base by height, and the area of triangle have the area of parallelogram, so equal half times base times height. Now, look and listen to another video to more understanding.
How can you find the area of a triangle? Think about this question during the lesson. A parallelogram can be decomposed into two identical triangles. How can you use the formula for the area of a parallelogram to find the area of a triangle? Describe how you can find the area of a parallelogram. To find the area of a parallelogram, multiply the base by the height. Reason abstractly and quantitatively to find how the areas of parallelograms and triangles are related. The diagonal of a parallelogram divides it into two identical triangles. How do you know that the two triangles are identical? One triangle can be rotated onto the other triangle. The heights, bases, and angles of the two triangles are the same. Identical triangles have the same base and height, so the triangles have the same area. The area of one triangle must be half the area of a parallelogram that has the same base and height. What is the formula for the area of a triangle?
Select your answer.
The area of a triangle equals 1/2 the base times the height. Now you know how to find the area of a triangle.
Okay, now the practical part. Hi guys, yesterday we talked about the area of rhombus and parallelogram. Today we talk about a new shape, triangle. The area of triangle. The area of triangle equal half times base times height. Okay, what's the meaning by base and height? Base and height, it means a line perpendicular to base. So perpendicular, look to the right angle. You see the height and the base. So we multiply half times base equals 4 and the height equals 2. Okay, we have two ways to make the multiplication here. We can multiply half by 4. Half times 4 equals 2. Then 2 times 2 equals 4. Or 4 times 2 equals 8, yes, and half 8 equals 4. Okay. Question number 4. Okay. The area of triangle, half times base times height. Excellent. Now half times which base and height? We have 3 lengths here. 3.5 inch, 4.2 inch, and 7 inches. Okay. The height, search for the right angle. So this is the height. The height must be drawn above base. What's the base here? Yes, 4.2 and the height 3.5. Now we multiply half times 4.2 and 3.5. Okay, we can multiply half times 4.2, then multiply the answer by 3.5, or multiply the two numbers, then divided by 2, which is easy. Okay, try to make half multiply 4.2. 4 divided 2 equals 2, and 2 divided 2 equals 1. Don't forget to put the decimal point. 2.1 multiplied by 3.5. Now we multiply 35 times 21. 1 times 5 equals 5. 1 times 3 equals 3. Then put 0. 2 times 5, 10. 0 and up 1. 2 times 3, 6 plus 1, 7. Add 5, 3, and 7. So the answer equal 735 inches square. The decimal point here after one place and here after one place. 1 plus 1 equal 2. So the decimal point must be after two places, 7.35. The last one, area of triangle equal half times base times height. Where is base and where is height? Height equals 5 and the base equals 6. Half multiplied by 5 times 6 equal, yes, 30. Half 30 equal, when we divided 30 divided 2, equals 15. The unit meter square. Okay, thank you and goodbye.